So do you have something in specific or general or anything?
I was just thinking like maybe just for right now, like go over um like in for chapter 3, for supply and demand and just maybe some of the um review equations, um just for like the general just like
Sure. Okay.
uh,
Um, let's see. I'm looking at exam 1 from 2021. Um, so you've got, all right, so
okay, and what question?
I am looking at question 6 on exam 2021.
Okay.
It's supply and demand kind of. Oh, that's
Hmm.
elasticity actually. Let's
Oh,
see.
I did want to do one of those also, so
Sure.
whichever one you want to start with.
Is that one? No, that rule. I don't know. That is really just a demand question. So let's do 7, which is which actually is a um, supply and demand. So, all right. So one thing I'm not doing with you guys that I did with prior class is I was giving them all the not inverted demand curves. So you're not going to have to do this because this is not how I've been teaching you. But you see how instead of P being in the excuse me, in the Y axis, it's actually Q.
Hmm. Yeah.
So I won't do this to you. You'll start the question will start with P over here. I mean, you should be able to look at it. I won't throw you off by doing that. So we have to solve to get this into the P position. Um, so we're going to add 2/3 P to both sides, and we're going to subtract Q from both sides. So 10 minus Q. And then we have to get rid of this 2/3 P. So we're going to multiply both sides by 3/2. And so that cancels this, and we get P is equal to 10 times 3 is 30 divided by 2 is 15 minus 3/2Q. Um, oh, it's 100, not 10. Sorry. So it should be 150 minus.
I thought something was off.
Yeah. Yeah. So this is where you would start. Like on my on the exam, you guys will have, I'll do something like D, the demand curve, D colon
Oh,
is
okay.
P equals 150 minus 3/Q. I won't make you do this, even though that's not particularly difficult unless
Hmm.
you don't read the question correctly. Um, so there's your demand curve. Then your supply curve, I gave it to them as QS equals P minus 25. So to get P on the right side, we're just going to add 25 to both sides. And so we get, for supply, P is equal to 25 plus Q. So then we want to, so with the supply and demand question, you're trying to figure out what the um, equilibrium price and quantity is. So you're going to set the supply and demand equal to each other. So you're going to do 150 minus 3/2Q equals 25 plus Q. And then you just solve for Q, which should be pretty straightforward. So 150
Yeah.
minus 25 is 125. Add 3/2 Q to both sides. So Q is really 1Q, which is 3/3Q. So that means we get 6/5 excuse me, not 6/5. Uh, it's, I'm sorry, 2/2Q, not 3/3Q. So
Mhm.
2/2Q, right? This is effectively 2/2Q. So 3/2 plus 2/2 is 5/2Q, right? And then we got to multiply both sides by
Mhm.
2/5 to get rid of the 5/2, right? So that cancels, and that is 50 equals Q. Yes. Okay, so now we have 50 equals Q, and we can take it and plug Q is equal to 50 into
Mhm.
either of these equations to get P. Probably the easiest one is this one, because it's just,
Yeah.
so P is equal to 25 plus Q, and Q is 50. That gives us 75. So if Q equals 50, P equals 75. So that is the initial kind of answer. Now, if we had, so let's remember, this is our supply, demand function.
Mhm.
This is our supply function. So we want to be able to draw this. And we know now that the equilibriums are 50 and 75. So
Mhm.
let's draw this. So this is, the slope is 3/2. The slope here is 1. So this is relatively steep. This is a 45-degree line. So, I mean, it's not critical to draw your graphs like super accurately, as long as you can, you can
Mhm.
work with them. So the supply curve, starting with supply curve, it's going to come up from the origin and go up at about a 45-degree angle, because a slope of 1 is a 45-degree angle. And it has an intercept of, right, just cover up the Q, it's 25,
Mhm.
right? And then it goes up with a slope of 1. The demand curve, we cover up the 3/2, and we know that it has a y-intercept of 150. So we can say that's 150. And then it goes down at 3/2Q. So if we want to figure out exactly where it crosses the x-axis, we set P equal to 0. So 0 equals 150 minus 3/2Q, and we're solving for Q now. So we get 3/2Q equals 150. Then 2/3, multiply both sides by 2/3. That cancels, and we get Q equals 2/3 of 150 is 100.
Mhm.
So this goes down like something like that,
Okay.
crosses there. Not, that's useful to kind of be able to visualize. And then we know this is the Q axis, this is the P axis. And Q is 50, P is 75. So that's our initial equilibrium.
Okay.
And then, if we keep going, we could say, all right, problem. Okay, so then C asks, what is the patient's consumer surplus? Okay, so consumer surplus is the area above the price
Mhm.
and below the demand curve. So it is this triangle. That triangle is consumer surplus. So what is consumer surplus then? It is the area of this triangle. So we want the base, which is, so this is the price line becomes the base of the triangle, and it goes out 50. So it's 50. So base times height. Height is 150 minus 75. A lot of people make the mistake of going up to the y-intercept and then they go all the way down to the origin, but
Mhm.
really it's just down to the price line, which in this case is 75 times a half. Um, so that is 75. So I need my calculator. So 150 minus 75 is 75 times 50 is 3750 divided by 2 is 1875. It doesn't ask, but we can also do the producer surplus, right? So if the area above the price line but below the demand curve is the consumer surplus, then the area above the supply curve but below the price line is the producer surplus. Right? And so the producer surplus is, again, just a triangle. The base is the width, right? And that's 50 times the height. So the height is, the highest point is 75, the lowest point is 25. So 75 minus 25 times 1/2. That's 50 times 50 divided by 1/2. $12.50. Okay, so that's the producer surplus. What else does it ask about? Okay, then it asks about a subsidy. So this is low is a, what is it, nurse practitioner? And the state is going to pay a subsidy. Effective immediately, Ms. Lowe will qualify for a $5 per patient subsidy. So that means she's going to get the money as the provider. So what does that do to her supply curve? Well, we said her supply curve was P equals 25 plus Q. And the 25 tells us where she begins in terms of her willingness, to produce. But if we can make it $5 less expensive by subsidizing her, she's going to be willing to produce more at the same price. So we can now say, well, what is her new, so let's say supply under subsidy, SS, is going to be P equals 25 minus 5 plus Q, right? Because it's going to be as if we're making it cheaper for her to produce. So that's hard for me to draw. I don't want to, I mean, if I drew proportionally, it'd be a super tiny line. So it's going to be a little out of whack here. But and even that's not a lot of room. So we're making it cheaper for her to produce. And so her subsidized supply curve is 25 minus 5, 20 plus Q. So now she is willing to produce where this subsidized supply curve crosses the demand curve, and the new intercept is 20, not 25, right? And that shifts it to the right, or you could say down, either one is acceptable. And so we need to figure out, well, what quantity is she willing to produce given where her supply curve crosses the demand curve? Well, nothing has changed about the demand curve. So the demand curve is still P equals 150 minus 3 over 2 Q. And so we're going to set the new subsidized supply curve equal to the demand curve. So 150 minus 3 over 2 Q equals 20 plus Q. And solve. So now we're going to subtract 20 from both sides, 130. And then we're going to add 3/2 to both sides. So we're back to 5/2 Q. And then multiply by 2/5. That cancels this, and then 2/5 here, and we get Q is equal to 52. So not a big change. Right. But she is willing to do 2 more visits under subsidy. So now we say, okay, so if Q is going to be 52, how much is Miss Lowe going to be paid, and how much are the consumers going to pay Miss Lowe? Well, in order to figure out how much Miss Lowe is going to get paid, we have to draw the quantity line up from 52 up to her original supply curve. And so the amount she's going to get paid is not based on the subsidized supply curve, but actually on her original supply curve. P equals 25 plus Q, and the Q that we're considering here is going to be 52. So she's going to get 25 plus 52, 77. So when we draw this over, 77 is going to be the price that goes to the supplier. And the price to the consumer is based on where the quantity line crosses the demand curve. So that is, well, we could do it here. P equals 150 minus 3/2 times 52, which is going to be some funky number, I think. 3 times 52 divided by 2. I guess it's not that funky, 78, right? And then make it negative plus 150, we get 72. So we draw this line over and we get 72. Now, had we had done the initial calculation and said, oh, it's going to, her price, Miss Lowe's price that she gets is going to be 77, we could have just said, well, what we know is the gap between these two lines is 5, right? Because down here it was 5 and these two lines are parallel. So if down here it's 5, up here it's 5. And so the gap between 77 and whatever the consumer price is going to be equal to 5 too. So 77 minus 5 gets us 72. Okay. So, so this is the price to the producer. This is the price to the consumer. And then the amount. So let's see. How much does the subsidy cost taxpayers? So sorry, so let me pause. Are you comfortable with what I've done so far?
Yeah, I just think once I practice it like a few more times, like the order of everything,
All right.
I'll like get a quicker grasp of it.
Okay. It does take practice, right? And so just to remember, from an intuitive perspective, under a subsidy, the consumer is paying less and the producer is getting more. Under a tax, the consumer is paying more and the producer is getting less. It's an inversion, right? The opposite effect. So under tax, these two positions are flipped. So you have producer price to the consumer and price to the producer are here. So now the question is, how much does the subsidy cost? Well, that's this box here is the subsidy. So calculating the area of a rectangle is pretty straightforward. It's the width, which is 52, times the height, which is 77 minus 72, 5, right? Which we knew. So 5 times 52 is 260. So that's the area of this rectangle, and that area of that rectangle represents the cost of the subsidy. Now, what is the consumer surplus? What is the consumer surplus with a subsidy? Well, the consumers wind up getting more, right? If I said, how do you get the consumer surplus? You go to the price line that the consumers are paying over the demand curve and up. So the original consumer surplus was here. Now it's all the way down here. So it's a bigger area. What is the producer surplus? Well, the producer surplus is getting more. The producer is getting more too. Their surplus is at the original supply curve up to the price that they get and over. So they're getting this much. I won't color the whole thing in, but I want to make the point. So we have the yellow comes down to here and over, and right, the whole thing is yellow. This whole thing is consumer surplus. This red triangle is producer surplus. And so the producers get this much of the subsidy or this much of the subsidy. Consumers get this much of the subsidy. And then we have this section that neither triangle captures here. This is badly drawn, but there's this little triangle here that nobody gets. And that is, do you remember what that's called?
I don't 100% remember.
It's not alive. It's dead. Dead weight loss, right? It's our dead weight loss. Yeah. Right. So this is the waste, right? From giving a subsidy. Why is it a waste? Well, the producers don't value it. Their red triangle doesn't cover that area. The consumers don't value it. And so nobody gets to have that. That's just the cost of giving out a subsidy, is that there's some dead weight loss in the process. So we can calculate the value of the dead weight loss. It's a triangle. And so its height or its width, its base is 52 minus 50. So dead weight loss in this case is the width, which is the additional quantity. So that's 52 minus 50, which is 2, right? And the height, which is 77 minus 72, 5 times 1/2. So 52 minus 50 is 2, times 5 is 10, divided by 2 is 5.
I see.
Now, you could also calculate the consumer surplus. I mean, I can if you'd like. We can calculate the new consumer surplus and the new producer surplus, and we could compare how much additional did they get. I mean, it's pretty straightforward. Go ahead and do that if you want. So that would be. So the new producer surplus under the subsidy starts at 25 and goes all the way up to 77. So 77 minus 25, that's the height. The width is now not 50, but 52 times 1/2. So we get 77 minus 25 times 52 divided by 2 is 1352. So producer surplus went from 1250 to 1352. And then the new consumer surplus is the height is 150 minus 72, as opposed to 150 minus 70, the original 75. And then it goes all the way over to 52 times 1/2. So 150 minus 72, 78 times 52 divided by 2 is 2028. So, as opposed to 1250,
Mm-hmm.
right? So, okay. Dead weight loss, subsidy. All right. So that's basic supply and demand with kind of those kinds of questions. We could do some theory real quick. So like we had that nurse practitioner had some demand, price and quantity. What might cause her demand to shift out to the right to D2? Let's think about things that could do that. You remember anything from any of those ideas from class?
So how she would shift it to the right?
Yeah,
If there's a if there's an increase in demand.
right. Well, that's what the right shift. So we're thinking about what is it that would make at a given price, all of a sudden everybody would want more of something.
Yeah.
So one would be population,
Mm-hmm.
right? So an increase in population. So if there were more people, so remember my story about the dentist offices, right? So
Yeah.
as the population of the town grew, there was a right shift of demand for dental services,
Mm-hmm.
along with a right shift of demand for chicken places,
Mm-hmm.
right? So, but that would be true for all medical services, right? So as population increases, there's a greater demand for more more medical services of all types. An increase in income. So if people get wealthier, they want more of more goods, right? They want more
Just
things that are
more
good,
products.
right? And then if another reason that the demand might shift is a increase in the price of substitutes. So if there's an alternative good for your service or the service you're considering, usually the existence of a substitute reduces the demand for the good you're considering. So for example, what's a good substitute for a nurse practitioner?
Like a medical doctor or
Sure.
like an LNA.
Probably not an LNA because they can't do diagnostics, but a
Oh,
medical
true. Medical
doctor, a
doctor.
PA,
Mm-hmm.
telehealth, right? There's a bunch of stuff you could think
Yeah.
of. So let's say that the price of, so let's stick with a physician, right? So physicians and nurse practitioners, in some sense, are in some areas, well, not all, but in some areas, are substitutes for each other. So if the price of a physician visit goes up, people will be more likely to go see a nurse practitioner.
Mm-hmm.
Right? So when the price of a substitute, for example, physician services increases, the demand for nurse practitioner visits shifts out and to the right to increase. So this is, let's call this nurse practitioner. So we stick with what we're talking about. Another way that what else would cause a right shift of the demand curve? Well, a decrease in the price of complements. So let's think about two things you consume together with nurse practitioners. So maybe if pharmaceuticals had a secular decrease, so they all kind of went down
Mm-hmm.
in price, well, it's not uncommon that when you go to see the nurse practitioner that you're going to get a prescription. So if the prescription is cheaper, then your overall, because you're thinking of the visit to the doctor or nurse practitioner in this case as a package where you're paying both to see the nurse and to buy some drugs. Well, if the price of the drugs goes down, then the overall cost of the package goes down, which then makes you more able to buy more visits to the nurse practitioner. And so price of complements goes down. Thinking what else? Those are the big ones. Yeah, if you can remember those, that's good.
Okay.
And so there you go. So demand for nurse practitioners, and then we can talk about supply of nurse practitioners. So how much is Miss Lowe willing to provide? Well, if the cost of inputs goes down,
Mm-hmm.
she'd be willing to provide more at the same price, right? So a right shift at P1 without changing price, right? She's willing to produce more. So cost of inputs, let's think for a second. That's the one I usually focus on. Yeah, I'm not bringing any more up in my head right now, but that's kind of probably the biggest one.
Okay.
So that's an important one to remember. There's complements and price of complements in production, which is kind of cost of inputs anyway. Yeah, that's good enough. So there's a list in your book. You should review that. I should probably review that because I'm not bringing them up in my head immediately. Okay. What else? Then we could think about elasticity. Right. So relatively elastic, relatively inelastic. How do we interpret that? Well, for a change in price, right? From if we start at P1 and then go to P2 with regard to D1 versus D2. So let's say that, so this is a relatively elastic demand. So going from P1 to P2, a modest increase in or decrease in price. We go from Q1 to Q2. It's a pretty big jump. But with regard to demand curve 2, at P1, we have Q1, and at P2, we have Q2. That's a pretty small change. And so with an elastic demand curve, right, relatively elastic demand curve, we're going to see a larger response, a larger a larger quantity response to a smaller change in price. And for a relatively inelastic demand curve, it takes a really big change in price to get even just a small change in quantity. So this one is elastic. This one is inelastic.
Okay, that makes more sense.
Yeah.
At first, like, I wasn't really like confusing the two of them. I think I just wanted to like visually like just like understand a little bit more like what makes something like more elastic versus like less elastic. Like
Mhm.
I think the example you did in class is helpful, like when you said like how some facilities, like if you want more nurses like compared to like an LNA, like the nurses need like 4 years of schooling
Right.
compared to like an LNA that needs like two or something like that.
Right. So that would be more about supply elasticity than demand elasticity. But yeah, yeah. So the big thing for either of them is really whether there are substitutes or not. That's the main driver for elasticity. And one of the ways that you can generate substitutes is through time. So a general rule is everything is more elastic with more time because time allows us to come up with substitutes, right? So, if you're having a heart attack, your demand for an emergency room is pretty inelastic. You need care right away, or you have, a potentially life-ending event happening. Whereas your demand and so you don't have much time, right? Because you have relatively little time, you're not going to have the ability to generate many substitutes. If you're having a heart attack or someone you care about is having a heart attack, you're going to take that person to the closest ED. You're not going to be like, well, let me think. That ED is going to charge 10% more than the other one. So I'm going to go to let's drive just a little further. It's only 5 more minutes and we can get to the cheaper ED. Right? No, your person you care about might be dead by the time you get to the cheaper ED, right? So you're going to go to the closest one. And the big issue there is time. But when you have something like, I don't know, I have a wart on my toe and I want to have it removed. Well, that is not an emergency, right? You could go weeks with that. I mean, it's maybe unpleasant and unsightly.
Mhm.
Um, but nobody's going to die from a wart. And so you have a lot more time, which opens up a lot more substitutes. So you could kind of shop around, ask your friends, hey, who's a good wart doctor? you know,
Yeah.
not really a specialty, but you know, um, where can I get the cheap, who does the cheapest wart treatments? And so your demand becomes much more elastic because you have more choices in terms of substitutes. Um, with with supply, the same general idea applies, right? So that's a relatively inelastic supply curve. That's a elastic. Right? And again, it is small change in price. So let's go here. So let's say we start at P1 and then we go to P2.
Mhm.
So with the elastic supply curve, this is supply. With the elastic supply curve, a small increase in price results in a much bigger, right? Importantly, it's the size of the relative size of the change in quantity to the relative change in price. The relative change in quantity, the gap between the two Qs, is much greater than the change in P's, right?
Mhm.
So that is your same as we had up here, right? This means this is elastic, much more willing to supply. Over here, at P1, we have Q1, and at P2, we have Q2, right? So it's an increase. There's more. It's just not, it's relatively speaking, the size, the increase in price is greater than the percent increase in price is greater than the percent increase in quantity.
I
Right.
see. That makes more sense. Because like, yeah.
Yeah. And again, it a lot of it has to do with substitutes. We'll talk later when we get into marginal costs. But really, it has to do, how steep the line is, has to do with how much is the cost of generating an additional unit increasing at an increasing rate. So like if going from 1 to 2 is 2, and then going from 2 to 3 is 4, and going from 3 to 4 costs an additional 5, then you've got a really steep one, right? And how do those come about? Well, things like, getting additional units here is expensive and costly. So if you have to go into the market and buy up all the supply of something, you're going to bid up the price. So inputs into your production, right, will, if they increase rapidly because of, for some reason, then you're going to have a much more inelastic supply.
Mm-hmm.
Likewise, the example I like to use is compare in medicine and healthcare, the supply of doctors is always going to be less elastic than the supply of, say, LNAs, right? Because an LNA, a licensed nurse assistant, it takes, I don't even know, like
Less
6
time.
weeks, something like that, to get trained.
Less time.
Right. Whereas a doctor, like even the shortest residencies are 3 years long. So you're talking about medical school, 4 years, well, first you're talking about undergrad, 4 years, medical school, 4 years. And then, family medicine or internal medicine is 3 years. So 4 plus 4 plus 3, that's 11 years as opposed to, say, 6 weeks, right? So to get one more doctor, it's a lot more, there's a lot more cost involved. And so there's a lot more sacrifice for each additional one.
Mm-hmm.
And so you see the supply of them is much more inelastic. But again, with enough time, even the elasticity of physicians starts to turn down as we find substitutes in production, right? Or people realize they can substitute over from something else. If you have enough time, you can get more substitutes. So time always makes both supply and demand more elastic. All right. So that's
That makes more sense.
Yeah. All right. So that's the theory. Maybe we could do number 6.
Okay.
That's an elasticity question. So that says we've got test 1, test 2.
Mm-hmm.
I'll just write it here rather than, and then the price and the quantity. So the price is 180. And 20 and 40. So the elasticity of demand is going to be change in quantity. It's percent change in quantity divided by percent change in price, right? So if price changes, how much does quantity change? And so we use the midpoint elasticity. So we're looking for kind of the average.
Mm-hmm.
So what is the average? And it is, it's going to be Q1 minus Q2 divided by Q1 plus Q2 divided by 2. So we're taking the change divided by the average. So and then same over P1 minus P2 divided by P1 plus P2 divided by 2. So that's the whole equation. So let me go over here. So Q1 20 minus 40 divided by 20 plus 40 divided by 2 all over P1 100 minus P2 80 divided by 100 plus 80 divided by 2. And so we get 20 minus 40 is minus 20 divided by 20 plus 40 is 60 divided by 2. So that's 20 over 30. And that's a minus 20, right? Divided by 100 minus 20 is 20 divided by 100 plus 80 is 180 divided by 2. So 180 divided by 2 is 90. So 20 over 90. Sorry. So this is getting kind of messy. Let me,
I'll divide that. That's 0.222.
Probably. Let's so let me, I'll finish it real quick. So I've got negative 20 over 30 divided by 20 over 90. I can get rid of the 20 over 90 by multiplying. I can invert the denominator. So that's the same thing as minus 20 over 30 times 90 over 20. Right. And now I can just cancel and be like, okay, 20. So that's minus 1 and 1. And then 30. And so I get minus 1 times 3 is minus 3 divided by 1 times 1. So I get minus 3 over 1 or just minus 3. So I'm not sure what you may have rounded a bit.
Yeah, I think I accidentally started to divide too early.
Yeah, so I mean, I would practice doing it the way I just did it with the fractions because you'll get a more accurate number. As long as I can follow your math, if you're off because of rounding, I won't, as long as I can see what you were doing, and if I can see, okay, that's probably a rounding error, I won't take any points off. But you might think about trying to practice.
Yeah, I definitely will. I have been doing it like that. I think just now I just started to divide.
Jump for the calculator.
Then finishing it.
So our elasticity of demand is minus 3. Elasticity of demand is always negative.
Okay.
Right? It's always going to be a negative number because the demand curve is a downward sloping line. And these are, so the changes, a change in price, a decrease in price is always going to cause an increase. So if I go from P1 to P2, I'm going to have Q1 to Q2. So price and quantity move in opposite directions. If I increase price, quantity goes down. So it's like if I have a positive change in price, I have a negative change in quantity. If I have a negative change in price, I have a positive change in quantity. So the relationship is negative, right? So that's why demand elasticity is negative. The opposite is true of supply. The elasticity of supply is always positive, and you calculate the elasticity of supply exactly the same way. Change over percent change in quantity for a percent change in price. So in this case, right, if we go from P1 to P2 and it's an increase, we go from Q1 to Q2, right? So when P goes up, Q goes up. When P goes down, Q goes down. So there you have a positive elasticity. So if I ask you, is -3 relatively elastic, relatively inelastic, or unitary elastic? What you want to do is take the absolute value. So 3, and you want to say the absolute value of 3 is 3, 3 is greater than 1, so that is elastic. If you had, say, 1/3, right, 1/3, that's less than 1, so that's inelastic. With, excuse me, elasticity of supply, you're going to have something like, it'll be something like, 1/2. Well, you don't have to take the absolute value of it because it's already positive. And you'd say, okay, 1/2 is less than 1, so that's relatively inelastic.
Mhm. Yes. That helps. That cleared up a lot.
This exam has a futures question. I won't ask any of those,
Okay.
just FYI. What else can I do for you? I've got to get going pretty soon.
Okay.
We started late.
I sent an email because I wanted to come in person, but I forgot I picked up like a double shift, so I'm working 3